Question 1 talks about what is the equation for linear momentum. Momentum is a vector. It is the product of mass and velocity, as you can see. And the direction of momentum is, of course, along the direction of velocity. And its unit is not as there, but it's kilogram meter per second. So that's what you mean by linear momentum. Second question says an object of mass 100 gram has a velocity of 25 meter per second. What is its momentum? You just got to multiply it, but you have to, what did I do? But you have to remember, see, that's what happened. And you should get 0.1 times 25, which is 2.5 kilogram meter per second. All right. Question 3 says, if the object in question number 2 collides with a stationary object of mass 200 gram and they stick together after collision, what would that collision be called? Is that an elastic collision or an inelastic collision? Actually, it is a perfectly inelastic collision. Yeah, it is an inelastic collision, but that is the type of collision where maximum kinetic energy is lost. So we could call it a perfectly inelastic collision. Now, what is the common velocity after collision? You know that the total momentum before collision is equal to the total momentum after collision, which is what is coming up on the screen. And then one of them is stationary, so that momentum becomes 0, which is the second one. So that is nothing. And then because they have a common velocity, you can combine their masses, can't you? And then calculate that velocity. All that remains is the math there. And you should get 8.33 meter per second. Number 4 says, is the kinetic energy conserved in such a collision? I already told you it is not conserved. In fact, maximum kinetic energy is lost. If not, calculate the kinetic energy lost. I did not do that. So can you take it from there? Can you find the kinetic energy lost? Yeah, so that's what you do. You find the initial kinetic energy, find the final kinetic energy, and take the difference. You get the kinetic energy lost. Now, taking it one step further, what form would that kinetic energy lost appear as? Because energy can't just fly away. It has to be somewhere. It is lost. So it's no longer in the form of kinetic energy. But what is it now? Where is it? Where is that kinetic energy gone to? A little bit of sound could have been produced, but most of the time it's thermal energy. It's heat. You know, it's heat. Most of the loss of heat, loss of energy is in the form, loss of energy is in the form of heat. Okay. Impulse, there are two formulas for impulse. Impulse is either the product of force and, actually, the product of average force and time, or it is the change in momentum. So those are the two formulas. Impulse is either average force multiplied by time or the change in momentum. And of course, the change in momentum is mass times difference in the velocities, as you can see. It is an easy question, but if you read number 6, you understand that the ball was hit straight back. It was moving at 10 and it is hit straight back. Usually students don't even care about that. But you know that in this case you'll have to take it as negative. So if you take the initial velocity as a positive, you'll have to take the final as either way. Or you take the initial as negative and the final as positive. So if you do that, then you would get the change in momentum. You're trying to find the change in momentum, that's m times change in velocity. Mass is 0.1 kilograms. I took the initial as positive, so I'm taking the final as negative, as you can see, and therefore I would get 3 kilogram meter per second. If you don't do that, you might end up with 1 kilogram meter per second. Anybody else? Anybody who got that as the answer? Be honest. So you got to be careful. If it's hit straight back, it has to be a different sign. Yes?
Can you leave your momentum as negative?
You could. There's no problem. You could leave it as negative. But the magnitude itself would have been 3, right? You would have got it as negative 3. That's what's important. You know that there are 2 ways to find impulse, isn't it? One is change in momentum. The other is the product of average force and time. So that's what you do. Just do average force multiplied by time, because the time is given, and set that equal to 3, because the change in momentum is the impulse, right? Okay. And then you would get the force as 30 newtons. So Eduardo, if you left it as negative 30, you would get it negative 3, you will get it as negative 30, which is actually, it makes a lot of sense because you hit it straight back. It's an opposing force. So, okay, center of mass of 2 objects. Masses 5 kilogram and 8 kilograms separated by 4 meters. The basic formula for center of mass is you multiply the mass with the distance, right? Add them up and divide by the total mass. So M1R1 plus M2R2 divided by the sum of their masses. That's all you do. And in this case, well, you didn't need... You know, I'm trying to say that you can fix the origin at one of the masses. In this case, it's fixed at 5 kilogram, you know. So in that case, the distance of the 5 kilogram from the origin is 0 because it's at the origin. See, that's the advantage of doing that. You know what I'm trying to say? Therefore, the 8 kilograms is at 4 meters. So 8 times 4, 32 divided by 8 plus 5, 13. That should be the answer. That's what I'm talking about. So you would get 2.46 meters. So you see, the trick is to put one of the masses at the origin. And if you had put the 8 kilograms at the origin, you would have got a different distance, right? You would have got 4 minus 2.46. Therefore, when you give the answer, you have to specify. You have to say 2.46 meters from the 5 kilogram mass. If you don't say that, at least your diagram must be there. You know what I'm saying, right? So, because you could have 2 answers in this question. You could have it as 1.54 meters from the 8 kilogram, or 2.46 from the 5, which is both correct.
Both would be right, we would just have to specify.
Right. Both would be right.
Okay, because I did it a different way.
Yeah.
Okay.
So you got 1.54, yeah, meter. Okay, going on to the 9th one. If one of the masses moves due to an internal force, what happens to the center of mass? Who can answer that? Stays at the same point. Internal forces do not change the center of mass. That's the point that I'm trying to give you there. Internal forces do not change the center of mass. And then I tried to explain the case of a boat and a person there. We did this problem, you remember? Switching sides and all that. I was just trying to say if there is the center of mass, and if the person switches sides, it's not going to move. That's what I was trying to say. I won't take more time on that. Number 10. If the 5 kilogram mass moves through 3 meters, how much does the 8 kilogram mass move? Once again, it's a ratio. The heavier mass will, of course, move through the smaller distance, isn't it? The heavier mass will move through the smaller. So how will you do that? It says 5 moves through 3, so 5 times 3 is equal to 8 times x, and find x. That is what you do. What I did is I took the ratio of the masses, which is 8 by 5, isn't it? Right? And then you have to remember that the heavier mass moves through a smaller distance, so I reversed it and did 3 times 5 over 8. Yes, Austin?
Can you use the ratio of masses to find the center of mass as well?
Of course, that's what we did. When you say M1R1 plus M2R2, you're using the ratio of masses.
Because I did different than you.
Yeah, but you have to be careful. If you use the formula, you'll never go wrong. If you try to use ratio, you may go wrong. 11th one, where is the center of mass of these three? 1, 2, and 3, kept at the vertices of an equilateral triangle of length 2 meters. That's the diagram that you see. Use the same idea as before. Try to set one of them at the origin. If you set one of them at the origin, then what will be the distance of this? Tell me. 2 meters. What will be the distance of this? 2 meters. See that? That's all. And use the formula for center of mass. I am going to draw the origin for sure. There it is. Those are the masses. Set the origin like that. So the first one is at no distance because it's at the origin. This is why I keep saying physics is easy. "12, 13. Okay, I did not write the answer to 12 because I said it. 0.2 times 100 is what? Whatever it is. How much is it? 20 kilogram meter per second. Momentum is just the product of mass and velocity. And 13 is not moving, so its momentum is 0. 14, the total momentum before should be equal to the total momentum after, so you just multiply the 0.2 with 100, plus the other one was not moving, so add their masses, 3.2, divided, you get the answer as 6.25 meter per second. Is that what you got? Okay. Because the second one is not moving, then you have 15. What is their initial kinetic energy just on beginning to move? You have their total mass. You have the velocity right there. You just use 1/2 times mass times velocity squared. That's it. 1/2 times the total mass times square of the velocity, and you get 62.5 joules. But what's interesting is, 16 says, what should their final maximum potential energy be, assuming no energy is lost? What do you say? Yeah, 62.5 joules. That's why we set them equal. So 62.5 joules. And then 17 says, to what height will both of them rise up to? You set the 62.5 equal to mgh. Right? Yeah, and then when you do that, you will get the height. I don't know what you get, but you will get it. And do all, you get what, close to 2 meters? Maybe I rounded off, you get close to 2 meters.
1.99.
1.99, okay. And 18 says, is this an elastic or inelastic collision, and why? And that's a trick question because, I asked that after 17 and 16 and all that. So I'm saying, is this elastic or inelastic? Which one? The collision. I'm talking about the collision. Remember I told you the most perfectly inelastic one is when they get stuck together. What happened here? Did they get stuck together here? Yes, so it is a perfectly inelastic collision. Maximum kinetic energy is lost. But how people are confused is, because the initial kinetic energy with which they began moving is equal to the potential energy. That's after the collision. See that? That's after the collision. We are not saying that the initial kinetic energy of the bullet
So kinetic energy from
is, if you take the kinetic energy of the bullet,
it's all lost.
Would you get it to be equal to the kinetic energy of both of these when they start moving? Never. You know how much sound would be produced and how much heat would be produced. So students find it tough to make a difference between these two. They get mixed up. But I hope you got these two parts. Collision is inelastic. But after the collision, all the kinetic energy is converted into potential. Yes, go.
So anytime that things are stuck together,
I'm sure everybody understood that. The center of gravity is the point through which the weight is assumed to be acting. So, through which point is the weight assumed to be acting? Through 50 centimeters. Is this point fixed? Yes. No matter how many grams you hang on this, where you suspend it, the center of gravity never changes. It's for an object, it's fixed. So you got to remember that. So I did not write anything there because that's too much writing. And 20, if the meter stick is suspended from the 30 centimeter, what mass needs to be suspended? To be suspended, grammatical error, from the 10 centimeter to balance it. You have to draw a diagram, don't you? So the meter stick is at, hopefully I did that, yes. The meter stick is now suspended at the 30 centimeter. So that's the 30 centimeter there. And the weight of the meter stick, like I told you, is always acting through 50. So the mass, isn't it? And so the question is, what mass needs to be suspended from the 10 centimeters? You got to have a mass somewhere here to balance it. So that's the 50, that's the 30, and that's the 10. What's the mass? 100? If you calculate the torque about 30, then you get the 100 gram as 100 times 20. I can see it. Isn't it 100 times 20? Should be equal to x times 20. So it's 100 grams. I'm not trying to make you calculate. I'm just trying to give you the ideas. That's why I'm using numbers like this. 100 times 20. 100 times this distance, 20, should be equal to x times this distance, which is again 20. So, okay. Therefore, the answer to that is 100 grams. And then, what is the tension in the string? See, the second condition is that the total up force must be equal to the total down force. And here you have two down forces, that is 200 grams. So you could call the force to be 200 gram weight. Therefore, the tension should be 200 gram weight. That's it. The tension in the string should be 200 gram weight. Oh, this is when I'm calculating. Anyway, the log. I think I'm going to 22 when I did that, because 22 says if another mass of 200 gram is, did you read that? Added at the 90 centimeter mark. So I've just added a 200 gram at the 90 centimeter mark. Where do you have to add another string in order to keep it in equilibrium? And the tensions must be equal in the strings. So you have to add another string, and the tensions must be equal in the two strings. I'll give you time to do that because I don't think I did it. Don't complete it. Can you tell me what the total tension should be in both the strings? 400 gram weight. And so each string should have a tension of 200 gram weight.
Sure.
Yeah. So you know the tensions. So you just, now where will you calculate the torque? That's the important thing. Where will you calculate the torque? Just calculate it at one of the strings, either here or there. Okay, if you do it here, and I hope you're watching, if you calculate the torque about this point, how many clockwise do you see? You see, this is going to be clockwise. That's 100 times 20. This is going to be 200, that's also clockwise. 200 times 60, 60, right? Because that's at 90. Any other clockwise? No. And two counterclockwise, which is, one is this one, which would be 200 times x, because you don't know. Isn't that what you're trying to find? Where the string should be. So 200 times x plus, what do you have here? 100? 100 times 20. Put the math and find out. If an object makes 60 rotations per minute, what is its frequency? Frequency is just number of rotations in a second. So 60 divided by 60, 1 rotation per second. That's the frequency. And the only reason why I brought that in is because some students, they multiply with 60. That's why I brought it out. So you have to think there. 60 rotations in a minute cannot be 3,600 rotations in a second, which is what you will get if you multiply. That is, my goodness, awesome. But it has to be less. So it's 1 rotation per second. That's the frequency. 25. What is its angular frequency? 2 pi times f, omega. Angular frequency, omega is 2 pi times f. Therefore, it's just 2 pi times 1, but the unit is radian per second, or radians per second. And 26 says, if the object is attached to one end of a string of length 50 centimeter, what is its linear velocity? Okay, that's why I think I drew that diagram. Who knows how to get it?
It's going to be r times omega.
That's it. Linear velocity is r times omega. And I'm showing you the direction of linear velocity. It's always tangential, isn't it? Okay, r times omega, 0.5 times 2 pi, which is pi. And that is meter per second. Pi meter per second. Yeah, 3.14 meter per second, if you convert it. If it has a mass of 200 grams, calculate its linear momentum. That's like the 5th time you have to calculate the linear momentum. Yeah, for that 200 grams. What is its linear momentum? 0.2 times pi. Linear momentum is mass times velocity.
Oh, yeah.
So,
And we use the,
yeah, mass of that. And you get 0.628 kilogram meter per second. Is that right? I think we already talked about this, but the sound recording was off. And if I have to put it onto YouTube, I have to say it one more time. Angular momentum is the cross product of R and P. Remember that the cross product R and P is not the same as P cross R. The order matters. Then 29, what is moment of inertia? Yes, mr squared would be a formula, but you will have to specify that the distance is the distance of the particle from the axis of rotation. I just want to try something. Right.
It's not centered, it will fall to the side.
Exactly. So I just want to say that rotational inertia depends on 3 factors. Number 1, actually 4 now. The total mass of the object. Number 2, the distribution of the mass about the axis. You know that, right? The distribution of the mass about the axis. Number 3, the position of the axis. And number 4, the inclination of the axis. So rotational inertia depends on the total mass, the distribution of the mass, the position of the axis, and the inclination of the axis. And then I think this is on your formula sheet. I disk, right? But if I ask you what's the rotational inertia of a cylinder, what formula would you use? Same thing. A cylinder is just a thick disk. Okay? Remember that. mr squared by 2. Then I just want you to remember the rotational inertia of a solid sphere, 2 by 5 mr squared. 2 by 5 mr squared. Okay. What is angular momentum? We talked a lot about it. Angular momentum, I told you, is the cross product of r and p, or it is I omega, like you told me, isn't it? Okay. Oh, it says what is its angular momentum? Right. So you have to have the I and the omega, multiply those. That's going back a few questions. So you may have already forgotten the I and all that. So you would get that as the answer. mr squared by 2. mr squared by 2. Okay. Yeah? For a disk.
Yep.
There you have. That's the answer. 0.02. If a circular part of radius 5 centimeters is cut out right from the center, by how much does the moment of inertia change? Mass. I am taking 1 divided by the area of the original one, which is pi r squared. Isn't it?
Yeah.
I'm setting that up as the unknown mass divided by the new area. There. Pi's cancel, and I get the mass as 0.065 kilogram. As simple as that.
Is that a 0.2?
Yes, because it was 20 centimeters, wasn't it? Yeah. So now what you have to do is, you just find the moment of inertia of that part, which was cut out, which is same formula. You got the new mass, and get 7.8 times 10 to the negative 5 kilogram, meter squared, of course. So that's the moment of inertia of what was cut out.
So we would take the moment of inertia from and take the difference.
Take the difference. So to find the new moment of inertia, find the difference. It's just going to be a real small change, but yes,